All right, so well, our next part of this course, we're going to again continue on with measurement, but there's all different types of measurement, just like we looked at conversions in the first part of the course, and also even the Pythagorean Theorem. And what we're going to start off with today is all about volume, and we're going to look at the volume of different shapes. Now, what is volume? Well, volume is the amount of space that an object occupies. It's the amount of space that an object takes up. All right, now we are going to look at a couple of different shapes, but the volume of prisms is our first shape, and prisms can come in different forms. And what a prism's all about is that it is an object which has identical, so they're all the same, cross sections. Right? So in terms of what is a cross section, it's like a loaf of bread, only like a perfect loaf of bread. That would be a cross section would be each slice. And so if you looked at our shapes, we have a rectangular prism, a cube, which is basically a rectangular prism that's special. I'll get into that. And then we can also have a triangular prism. So if you were to slice this box, or you are able to slice this box like a loaf of bread, and this cube as like a loaf of bread, and the same thing down here with my triangular prism, if you were to slice it like a loaf of bread, you would have identical cross sections. All right, now the key thing here is we're going to use a couple of formulas today, and labeling these shapes. We have our first formula, or actually first two formulas, where V again stands for volume. All right, so that's our volume there. Now we have an L, a W, and an H. Now the H is our height, so that's how high up. Now, when you're talking about length and width, our L and our W, well, they could be on either side of the bottom. So I don't know, I'll put the width here down at the bottom and our length over on the side. The same thing with our cube, where we have, again, our height and our W and our L. Again, our length, our width, and our height. Now, the key thing here is basically a cube is a rectangular prism, but it has all the sides are equal. That's the only difference here. So a cube is just a special rectangular prism, just like a square is just a special rectangle. All right, so we have length is equal to height. Now on a shape, to show that, what you would have is these little tickies. And those little red tickies are showing that all those sides are equal. All right, now again, we have a triangular prism. All right, now it's again, we have our three variables. We have the base, which is the distance along the bottom. We have again our height. Now again, the key thing with a height in all the shapes that we're going to do is that it's straight up. It's always straight up, not on an angle, but straight up. And then we're also looking for the length of our triangular prism. Now, this formula could also be written a different way. And it's right now, it's 1/2 base times height times length. I also have seen this, and I'm going to use the first one all the time, but it could be base times height times length, except for instead of timesing by 1/2, we could divide by 2. It is the same thing. All right, so if you're multiplying by 1/2 or you're dividing by 2, it's all the same. All right, so we're going to try some examples here. All right, so find the volume of the following. Now, one of the things I like to do is first identify the shape. And in this case, we have our rectangular prism. All right, so again, our formula there is volume is equal to length times width times height. Now, something that's really important, it might seem simple now, but it's to actually label the sides of your diagram. All right, so again, I'm going to say that 12 is my width, 4 is my length, and 6 is my height. I do this so that when I'm substituting into the formula, if I ever get mixed up, I can just look at my diagram and know which letter's which. All right, now I'm going to substitute into my formula here. So I have volume is equal to the length. Let's see, I look up. It's 4. All right, then I have my width, which is 12. And then I have my height, which is 6. And the best part about this formula, all I have to do is multiply the 3 numbers. So I get my calculator right here, and I go 4 times 12 times 6. I can do it all at once here. And I get 288. Now, we get to the next part, the units. This object is 3-dimensional. And so the units, and it's measured in centimeters, our length, our width, and our height. They all got to be in the same units. So it's going to be centimeters, and this is a 3-dimensional object. So it's centimeters cubed. All right. Now we get to our second shape here. Now I've only got one distance here, a 5, right? 5 meters on this one side. But see those little tickies? That's telling me that this side's 5 meters, and this length here is 5 meters. And so that makes this thing a cube, all right? So which again is just a special rectangular prism. So the formula is the same, where we have length times width times height. Now the best part about this formula, or this shape, is that you can't really mess up substituting in because they're all the same value. So I've got a 5 times a 5 times another 5. There we go. All right, and let's see. So again, get my calculator here. Hit clear. I got 5 times 5 times 5. Well, 5 times 5 is 25 times another 5. I get 125. Now again, this is a 3-dimensional shape where the length, the width, and the height are measured in meters. And so again, it's meters, and it's a 3-dimensional shape. So I put cubed. So it's 125 meters cubed. All right, what else we got here? Oh, they're down farther, way farther. All right. All right, so, well, look what we got this time out. A little 3 and 4, where we have 2 triangular prisms. All right, so now, again, if I look back at my formula here, for a triangular prism, what do we got here? We have 1/2 base times the height times the length. And again, look where our B are. You got to look at the diagrams there, and it tells us where to look for those variables on that shape. So again, B, the base, is along the bottom. Height is straight up. And the length is how long this triangular prism is. All right, so I go back to my shape here. It's way down here. All right, so I'm going to write out my formula, which again is the volume is equal to 1/2 the base times the height times the length. Now again, what I like to do always is label my diagram. All right, so I know where my variables are. Well, see this 4 here represents this blue line, so that's straight up. That's my height. All right, my 10 is that distance along the bottom, so that's my base. And, well, the 20 along the side here is my length. All right, so now I'm going to substitute in. Now, here's something that you're going to see me do a lot in this part of the course, is I got 1/2. And I know a lot of you don't like fractions. But the key thing here is that a fraction is just a divided by question that's not done yet. So if I get 1 divided by 2, as a decimal, that's 0.5. I don't like fractions either. So if I can get rid of it, I'm getting rid of it. Well, not getting rid of it, but if I can change it to a number, I'm changing it to a number. All right, now, again, this is why I label my diagram, because I got to put in base times height times length. So my base, I look at my diagram there. It's 10. All right, my height is 4. And then my length is 20. All right. So now I can multiply my four numbers this time. So I got 0.5 times 10 times 4, and then times 20. Oh, I end up with an even 400. Now, again, the units here, everything, the base, the height, and the length are all measured in meters. And once again, it is a three-dimensional shape. So I put meters cubed. All right, now, number 4. Check this out, is that we have, again, a triangular prism. But this one's not as easy because we got 4 numbers in there, right? So again, I'm going to write down the formula first. We got 1/2 the base times the height times the length. All right, so figuring things out. Well, this is a triangular prism. It's a different shape here, but straight up, there's my height. All right, and let's see here. Now I got to find, say, my base. Always the distance along the bottom. All right, distance along the bottom, just like here. So that's my 12 is my base. All right, and then I got to figure out which one's my length. Now, if I compare diagrams here for number 3 and number 4, see that 20 along the side here is my length. Well, that means my 10 is my length. Now, what's this 20? This 20, and this is something we're going to deal with when we deal with another shape, not today, is called your slant height, because it's your height put on a slant, where your real height, h, is straight up. All right, so we just have a little extra information in there that's just there to confuse us, right? That happens. All right, so I'm going to plug all my information into my formula. So I got my volume is equal to, again, 1/2. Again, is a decimal. Let's get rid of that fraction, right? It's just a divided by question, not done yet. So 1 divided by 2 is 0.5. My base is 12. My height, let's see, look at my diagram here, 16. Okay. My length, again, looking at my diagram, is 10. All right, so now I multiply my 4 numbers. So I got 0.5 times 12 times 16, and then times 10. And this time I get 960. Again, we're talking about units. All right, when we put our units in here, this time everything is measured in centimeters. And it is a three-dimensional shape because it's something we can handle. It sticks up. There we go. Oh, okay. Next one up here, number 5. Just checking the chat here to see if there's any questions. All right. All right, so next up here, number 5, again, look at, we got ourselves a rectangular prism again. Kind of looks like my Toblerone bars, which are one of my favorites. All right, now, again, I'm going to write down my formula here. We got V is equal to 1/2 base times height times length. All right, so again, looking for my values, my base, all along the bottom here. So that's my 8. All right, I have this distance along, how long this triangular prism is. So that's my length. Now I got a bit of a problem here. This 5 is this red line here, which again is my slant height. And see the H there is missing. Now, so I want H, E, I don't have it. Now 8 all the way across the base here is 8, which means this is 4 right here. Okay, so I don't have my H. That's a problem because I'm going to need that for my formula. Anybody have an idea of how I'm going to find H? Because I don't have it right now. The little hint there is I got a little box there. It's a right angled triangle, and that I've drawn in red. Anybody have an idea how I'm going to find that? Little hint here we did in our last part of our course, the first part of the course. Well, when we got ourselves a right-angled triangle, we can use the Pythagorean theorem, where we have a squared plus b squared is equal to c squared. Now, again, a little recap of the Pythagorean theorem is that the c is the important one, right? And it's always across from the right angle. So it looks like our c is going to be 5. All right, so I'm going to have to find my h. Going to do some extra work here before I find, or I'm going to have to find my h before I can substitute in the formula. So, well, 5 is c squared. So instead of c squared, I'm going to put a 5 squared. And again, with the Pythagorean theorem, the other sides are just the other sides. So I'm going to say, I guess 4 is a. So instead of an a squared, I'm going to put a 4 squared. And b is our height. So instead of b squared, I'll put a h squared. All right, now 4 squared is 4 times 4, which is 16. Plus h squared. All right, and then 5 squared, I can figure that out. That's 5 times 5. 5 times 5, well, that's 25. All right, well, I got to solve for h. I got to get h by itself. So first thing I'm going to do is I'm going to move that 16 over to the other side here. All right, so now what I'm going to get is h squared is equal to, I got that 25 over on this side of the equal sign. But when that 16 moves over, and I've said this before, when it changes sides, it changes sign. So it was a plus 16. Now it's a minus 16. All right, well, still doing some math here. Let's see, 25 minus 16. 25 minus 16 is 9. Now, I've got h squared by itself, but again, I want to get h by itself. So I got to get rid of this little 2. And the only way to get rid of an exponent, that little 2 there, is take the square root of both sides. And so I got to type into my calculator here, the square root of 9. What number multiplied by itself will give me 9? Well, the answer is a 3. All right, so I'm going to label my diagram here. I found it. It's a 3 is my height. All right, so now I have my base, I have my height, and I have my length. So I'm ready to substitute into my formula here. So I come back up to my original formula. All right, and again, that's why I labeled my diagram, because it kind of sidetracked a little bit. So now I can look at my diagram, get everything in there. Again, 1/2, we've already done that. That's 0.5 as a decimal. My base, now half of the base was 4, but the full base was 8. All right, my height, that's what we just figured out there using the Pythagorean theorem, is 3. And the length, got a lot of numbers on here, 15. All right, so now I pop it into my calculator here. I've got 0.5 times 8 times 3 and then times 15. I get 180. And again, when we're looking at units here, we have centimeters. And of course, well, a Toblerone bar definitely takes up space in my stomach, which this is a lot like a Toblerone bar box. So it is, again, a 3-dimensional object. And there we go. So we get 180 centimeters cubed. So we had a little Pythagorean theorem in there. All right, so we had to find work, a little extra. Now we're going to do one more shape here, and that is the volume of a pyramid. Now we can have a bunch of different pyramids, so that's the weird part. But we're going to stick to a couple normal ones. Oh, there we go. All right, now the volume of a pyramid is found by using the formula V equals A times H divided by 3, where A is the area of the base of the pyramid. Okay, so the area of the base. Now, we look at our pyramid here, and again, I'm going to go back to my formula here. It's V is equal to A times h divided by 3. Now this pyramid here, we have a height here, again, straight up distance, that blue line. All right, and that height is 12. Now down at the bottom here, you can see these little tickies. So if I was to stare down, straight down from the pyramid, all right, what we have is a rectangle. Kinda. Because it is a special rectangle, because all these sides are the same, which actually means it's a square. Now, the area of a rectangle, that's what we're finding here. The area of this bottom, the base of the pyramid, all right, is, let's see here. Well, length times width is the area of a rectangle, which again is this, a square is a special rectangle. And so if I take my length times my width, which is 10 times 10, well, 10 times 10 is 100. All right, so now I can go back up again. We had to do a little extra work here. So I look at the volume of my pyramid. I found the area of that base because it was a square. It's 100. We have our height. Again, I'd like to label my diagrams because, again, we're going to get into more complicated shapes. So I always try to label my diagrams. And again, sometimes we have to do a little bit of extra work like we did here with the area of the base. All right, times my height, which is 12. And again, I'm going to divide by 3. All right, so my volume here, I'm going to take 100 times 12, and I get 1,200, 1,200. And then I can divide that by 3. So I take 1,200 and I divide it by 3, and I end up with 400. And again, the units, when we're looking at the units here, we have centimeters, and a pyramid is definitely a 3-dimensional object, and so it is centimeters cubed. So again, this was a square-based pyramid, but we can have rectangular-based pyramids, or we can even have, well, there's a bunch of different shapes. We can have a triangle-based pyramid. We're only going to do rectangular-based pyramids, which could be squares.